Welcome everyone to a statewide water seminar this morning. Thanks for joining. We have an all-star lineup today. We've got Dan Nolan from Local Government Commission, Vanessa Marcadejas from City of Menlo Park, and Neil Shapiro from the City of Santa Monica. On the agenda today, we'll be looking at water conservation, water quality, capture, and use. And at the end, Daniel will give us a big picture of what's going on in California water, kind of tying in the examples we see from Vanessa and Neil. So first, I'd like to introduce Vanessa Marcadejas. She's the Environmental Program Specialist for the City of Menlo Park. What that means is she's got her hands in a whole bunch of different sustainability projects. She does everything from solid waste and recycling to climate action planning, energy efficiency, stormwater pollution, and finally, water conservation. Some of her more recent projects include the strategic plan for the improvement of public trash and recycling receptacles. She's compiled the greenhouse gas emissions inventories for the City of Menlo Park. She's also worked on a project to install solar in 4 city facilities. And the program she's going to be talking about today is the CivicSpark program, which I'll let her describe a little bit more in detail, but it goes hand in hand with a Bay Area-wide landscape replacement program called Lawn Be Gone. So without further ado, thank you, Vanessa, and I'll hand it over to you.
Sounds good. Thank you so much for the introduction and for organizing all of this. Okay.
Just a reminder to everyone, as Vanessa's running through her presentation, if you have any questions, please just chat them into the question bar on your panel. Thank you.
Okay, and can you see my screen? Just wanted to double check.
Yes, we can.
Okay, perfect. Thank you so much for CivicSpark organizing all of this, and thank you for taking the time and joining this webinar. And my name is Vanessa Marcadejas from the City of Menlo Park Environmental Services, and today I'll be talking about the city's CivicSpark Landscape Design Assistance Program, which Megan mentioned goes hand in hand with the city's turf replacement rebate program known as Lawn Be Gone, where we rebate residents and commercial customers in our water district $2 per square foot of lawn converted to water efficient landscape. A little bit about the Menlo Park Municipal Water District. We serve about 16,000 residents. What's unique about Menlo Park is we do have a total of 4 water districts, which can be one of the most confusing things to our community. We have the California Water District, which serves the center of Menlo Park. And the Menlo Park Municipal Water District serves the east and the west side of Menlo Park. We also have the O'Connor Tract Cooperative and the Palo Alto Mutual Water Company, which serves about 8 to 10 homes. And that's all based on the very unique infrastructure we have for water delivery. As Megan mentioned, we are a BOSCA member agency. We do participate in a number of their water conservation programs. We offer the high efficiency toilet rebate program, washing machine rebate program, Lawn Be Gone turf replacement, large landscape analysis program. That's where we offer monthly water budget reports to commercial customers and also offer a free $1,400 landscape analysis survey that they can take advantage of. We also have school and public information programs. And most recently, we were a recipient of the 2016 Silicon Valley Water Conservation Award. We were ranked for the highest cumulative water savings in the state at 47%, which means we exceeded our 16% conservation standard by 31%. Another program that we do offer in our Menlo Park Water District is we do host a total of 6 landscape education classes, covering everything from water efficient edibles to landscape design. A little bit of background of how CivicSpark was created is we did begin implementing the Lawn Be Gone rebate program in fiscal year 2012-2013. Back then we had only 2 participants, and we're trying to figure out how we can get people more interested in the program. We also did realize that it may take a while for folks to get familiar with the program, and also realize that landscape design and converting your landscape can be a significant cost. Going into fiscal year 13-14, we only had 5 participants, so we really wanted to change that. We did call and survey the previous participants for some feedback, and we did identify that landscape design was the greatest barrier. A lot of folks were interested in the program, had the budget to do so, but they were getting stuck after our pre-inspection phase, which is, they need to design what their vision is going to look like. They're really excited about it, but the execution was really hard to envision. So as the next step, staff went back to City Council to request the development, approval of the development of a new program for landscape design to fill that gap of the education. We also realized that homeowners may not have the knowledge or know how to go from a lawn and to what you see in the picture as an example here of putting in plant pellets that work together, putting together an efficient irrigation system that would make sure that those plants thrive for a very long time. We then put together a request for proposal, and that was issued, and we got a couple of bids for consultants that were interested. How we have the program set up right now is we chose Valier Design and Associates, and they have a very unique expertise. They've worked on large municipal projects and also residential designs, and we've been very happy with them so far. Our program launched in spring of 2014 with an annual budget of $10,000, and we were able to work out a really great and exceptional design package valued at over $400, which is the pricing that the city gets per landscape design that the consultant puts together for each participant in the Lawn Be Gone program. So how that works out is the customer contributes $50 and the city subsidizes $350. Going into the RFP process, our staff did do some initial research into how much these residential landscape design plans actually cost, and it can certainly vary by the size of the yard. And we were finding out that some consultants would charge 3 to 4 square foot for design, $65 to $100 per hour for designing, and we also found that some of the bids came in, or actually the research came in at $1,500 to $2,500 per design. So comparing that to $400, you're getting quite a great deal. So that's how the program setup works. What we did is the outreach. Learning from Lawn Be Gone, we did a significant outreach from that, and with the ConservaScape program, we really wanted to sell it as being a really great deal. We have information on the program on our city website, council digests and press releases. We have quarterly water bill inserts, ads in the local newspaper. The picture on the right side is actually an example of what we recently put in the Home and Garden magazine, which is from put together by the Palo Alto Weekly. It's distributed in our area and in Menlo Park as well. And of the 6 classes that I mentioned earlier, we do have 2 of those classes specifically taught by our actual landscape architect, Valier Design Associates. What's wonderful about that is those classes usually cap off at around 30, and we've had up to 50 participants sign up for those classes. And what's unique is they're able to get a picture of landscape design 101 from start to finish. All attendees are given a template that they can play around with and tinker with, so they get familiar with plant spacing and different elements they can put into their design. And at the end of the class, there's a really long line for our landscape architect with folks that actually come to the class with sketches, and he's able to comment, and so that's also a way they get free consultation services, which otherwise would cost be very cost prohibitive in some cases. How ConservaScape works is you have to be a Lawn Be Gone participant, so we have to have your application in our system. You need to submit a ConservaScape application with a $50 fee. The participant then completes a pre-consultation survey. And what that survey has is it's a survey where we compile the information to give to our landscape architect before they get on site to meet with a resident. That way, expectations are upfront, and some of the questions in that survey include what's the current use of the lawn, the theme and the style. Do you want something whimsical or shrubby? What type of colors are you interested? What's your budget? Did you want any hardscape elements in there? So asking these questions really gave our architect an idea of what the resident's vision is, so we can also make it realistic, but also ensure that this is something that's going to be a successful project, and the design and the elements are all going to thrive and last a really long time. The on-site consultation with the landscape architect then occurs. It's usually about half an hour to an hour, and then the landscape design plan is completed within 2 weeks and sent to the applicant once approved by the city. Our pricing structure as it stands right now, which will be changing in the upcoming fiscal year, is the $400 package fee. So this table right here is what we have on the participation application. We do want to list out the landscape services so the residents are aware of exactly what they're going to get. They get the initial landscape consultation, which is priced for the city at $125. The landscape design plan, which is a package of a couple elements at $200, and the plant and material inventory list, which is $75. Now, we did want to allow some flexibility in the program for additional services on top of the $400 that the city covers. And this is going to be in the case of if the resident wanted to go above and beyond the initial design plan that's provided to them, or more of an extended scope. And what would warrant these additional charges would be, for example, if the resident gets their design and they're like, it's not quite what I was looking for, I want it completely redrawn. We do allow that with additional costs and services, which a complete redraw would be at around $150. Any of these additional services would have to be covered at the expense of the resident. This table, also just for transparency and clear expectations, is the design timeframe. This is also on the ConservaScape participation application. It can take at a maximum up to 8 weeks for a landscape design plan. Typically, it'll take about 2 to 3 weeks. So you have the start of the Lawn Beacon project, and they fill out the application. There's a site consultation, and then there's a first draft of the landscape design plan. It's then given to the city for review, and that's for the city staff to ensure that the design that is put together does match Lawn Beacon program requirements. So, for example, the city does have a water efficient landscaping ordinance in which 80% of conversions, actually the 80% of the entire conversion has to consist of plants. So usually 2 to 3 weeks. This is a sample of one of the elements of the design plan. This is a planting and hardscape plan. This is a Lawn Beacon project that we had at 219 Haight Street. This is the Sanderson Garden, and very detailed. There's plant counts in here, species name, the size, the quantity. So this is one piece. Another thing that the participant gets is they also get a visual of some of the plant elements, especially if there's something that has a very strong color. This is attached to the landscape piece, the first piece that you saw on the slide before. They also get an irrigation plan, which, based on the plants that are installed and the hardscape in the area and the plant spacing, details what irrigation system should be put in, at what depth, again, very detailed. And the plan is also meant to be given directly to whoever the resident employs for the project, so they know what to follow and what's been recommended by our architect. There's also additional construction details if there are additional elements included in the plan, such as an umbrella planter that you see on the bottom right hand of this construction detail sheet. Any type of, for example, dry rock stream beds are very popular in our conversions, and sometimes there's details on how to include those, what type of rocks and spacing. I also wanted to show you, so Haight Street, this is the actual project site of the plans that I just showed you. This is a conversion area of 3,026 square feet And through the long begun process of converting from a lawn to the water-efficient garden, this site alone would save 78,676 gallons of water. Del Norte Avenue was also another Lawn Begun and ConservaScape participant. The conversion area was a little bit smaller at 947. Water gallons saved annually is 24,622. Ivy Drive, we've actually kept in close contact with this resident. They love the Lawn Begun program. They recently finished up their backyard conversion. This is a picture of their front yard, 1,114 square feet. Water savings in gallons annually is 28,964. This is a before and after, and this may look familiar because this is our one of our champion sites where we've been in close contact with them. We've used these pictures in our outreach pieces, like in the home and garden picture you saw earlier on our outreach slide. They did give us a year after photo, which is this is the result of that, which is a huge drastic change. So just going back one slide, looking at the left at that lawn, and then the conversion on the right side, and then a year after you really saw those plants grow out. And the residents also let us know that a lot of neighbors have walked by, some of which have applications in the system to convert their lawn. This is Nova Lane, also ConservaScape participant. Before and after picture, and this was more of one of our smaller sites, but I wanted to include this to show that converting your lawn to a water-efficient landscape, there's a misconception that it'll automatically look like a desert, and that's not the case. There's different types of mulch you can use, different types of plants. Some folks have also incorporated edibles as well. They wanted to show a range of that. Lawn Begun conversion participation, post-ConservaScape implementation. As previously mentioned, the first 2 years we have 2 and 5 residential projects completed. 2014 is when we started the ConservaScape program, and we got 11 participants. That has now jumped up to 40 residential participants, and it's not the end of the fiscal year. In these counts, I did not include projects that are currently in progress. So lessons learned and tips. We currently have the program set up to be a cluster. The consultant is in the San Rafael area, and so we initially decided to book 2 days out of the week, Tuesdays and Thursdays from 10 a.m. to I believe 2 p.m. for the appointments. We now understand that that's very cost prohibitive. We wanted to be mindful of the consultant as well with the travel time. So if what I suggest is there are other agencies who are interested in participating or starting a program such as this to maybe employ someone local that can either be on call, or when you go out and look at the bids, maybe employ maybe a number or more than one consultant. Establish clear program guidelines. The lawn conversion process can be overwhelming, which we've been told, and we want to make it as easy as possible. Most of our outreach, it used to be, we want to get all the details in there, but it's now been broken down to a minimum of 5 steps, and here's the references if you want to further look into the terms, so not to overwhelm people up front. Certainly begin the program with a soft launch. It can take a lot of people to get used to something like this. Some residents, especially in our area, have had different experiences with contractors, some good and some are bad, and some do have a loyalty to their existing contractor. So just letting them know that our contractor is very experienced, and we're happy to answer any questions. Also to provide visual resources and actual pre and post examples, such as the ones I provided in the slide. On our ConservaScape website, we do have information on how to participate in the program. We have a list that we borrowed with permission from the Santa Clara Valley Water District. Here's a list of Bay Area landscape professionals that you can contact either for design if you don't want to go with our landscape architect, or folks that can provide general service to put the conversion in. We also have links to sample landscape design plans on our website so they know what to expect. Lastly, staff support to ensure a great customer experience is essential to the longevity of this program. So through the Lawn Begun process and ConservaScape process, we have a staff member in our environmental programs department assigned to that project. And we see a lot of back and forth emails and phone calls. We want to let them know that we're here to answer any questions that they have. And with that very personable customer experience, we are seeing a lot more successful projects being conducted because we do give them the confidence that if they're stuck, we can help them figure out why it is that they're stuck, and if there's a resource to help find a solution for that. So this is my contact information. Again, I appreciate your time, CivicSpark, for putting this together, and I'm available to answer any questions that you have.
All right, thank you, Vanessa. We do have quite a bunch of questions coming in on the queue. The first question that we have has to do with funding. We are wondering where the funding for the city's subsidy comes from, the $350, and also since the $400 cost only covers the design, what other expenses do participants expect to incur?
Oh, I may have lost you on half of that. I don't know if it's my connection. Can you say that one more time? I apologize.
Yeah, sure. We're wondering where the funding for the city's subsidy comes from, so the $350 that the city contributes. And then we're also wondering, since $400 only covers the cost of design and not installation, what other expenses do participants incur?
Oh, I see. Okay. So first of all, the funding for the program does come from, so environmental, we are funded by different areas. We have solid waste, water conservation. So we did not increase any type of fees to our water customers at all to be able to fund this program. This is something that we had to compete with. I believe the funding is from our general fund put into our water fund specifically for all BOSCA programs. So I hope that answers your question. And in terms of additional expenses, so the $400 covers the landscape and hardscape plan, irrigation plan, and construction details. Additional expenses that they incur would be the construction costs afterwards. The plant ordering, the rental of equipment. Some of our residents have done a combination of hiring a contractor to put the full conversion in, and they're priced depending on which contractor they select. And some of them have gone the, I'm going to put the installation in myself. I'm going to take the plans and do a couple YouTube searches, which those have actually worked, and they have rented the equipment themselves. So each project is very unique and varies into what additional costs they incur.
That's great. Thank you so much for that information. Another question that we have is that a lot of fellows in our program are actually working to recruit people, residents, for trainings and other events. What was the most effective way that you recruited participants to your Lawn Be Gone courses?
Oh, in terms of outreach, so the outreach is definitely key. We've really gotten into trying to stay up to date on social media as much as we can. We found out that a lot of neighborhoods and communities are now using Nextdoor. I don't know if you're familiar with that. So Nextdoor, you start an account based on your zip code, and neighborhoods put together their own kind of chat groups, and they share information. And we find that very effective because it has a concept of gamification. Residents don't want to be left behind. What is my neighbor doing? And that's how information has started to grow. Another effective way is the in-person workshops. So it's very low risk. You don't have to pay for that. The city pays for our designers to come out. We advertise for that, and folks can spend a whole hour learning about our program and what they're going to take from it. So yeah, has helped out a lot. Facebook, Twitter, Nextdoor has been very significant. And on Facebook, I believe if you're an agency, you can have additional blasts, which further reach out to not only your customers, but other folks who may know people in the area.
Awesome, thanks. We have time for one more question. So it sounds like your community outreach campaign for CivicScape and water conservation in general has been pretty extensive. Describe how this campaign was developed. For example, was there a committee that decided which avenues to pursue, or was there a specific outreach person?
Actually, that's a very good question. Prior to ConservaScape, it was mainly the environmental program department. We're very small. We have a staff of about 4 people, 3 of which are full-time and 1 is an intern. And it was mainly developed within our group at the direction of the city manager. And we also have an environmental quality commission that we would update them on the efforts that we have. We're creating a new program. The environmental quality commission is made up of 7 members of the community. They're also residents. And so we really wanted to show them samples. You know, what are your thoughts on the sample piece? Is the messaging need to change? Is it something that resonates with you? Is this something that your neighbors may be interested in? So we got feedback from them as well. And then recently, we, just in the past 2 years, we have a new graphics and designs team, which we hired a graphics designer to have very consistent messaging. This isn't only within our water program, this is within every single city department. So we created a brand around water conservation, so a lot of our residents started to see the same type of symbols and pictures that we use. We started to take the route of not overwhelming with too much information, but just the right information up front to hook them so they can visit our website. What's also effective is our website. We have a new analysis system where we can track the number of clicks and what people are looking at the most, what they're looking at the least, and we also have a feedback system called Comcate where folks can chime in and say, you know, I have a question about this, or I really would like to see this change. So we have a very active community, and we've been very fortunate to have these additional resources so we can start to brand our water campaigns.
Wow, that sounds incredible. Drew and I work in the same office of sustainability up here in the Bay Area for San Mateo County, and we've done the same thing. We had a marketing company come in and work with us on branding. So hopefully other fellows out there have offices that are doing the same thing. If not, could be a good idea to bring up. That concludes our Q&A with Vanessa. She's got to run, and we really, really appreciate your time, Vanessa. Hopefully you'll get some emails popping over to you for questions. Yeah, so thanks. Thanks for joining.
Yeah, thank you. And for all the attendees, feel free to email me. I'm also happy to have you know, phone calls with each of you to further talk about lessons learned. So I really appreciate it. Thanks again.
Thanks, Vanessa. Next in the line.
Bye.
Bye. Next up, we have Neil Shapiro. We're going to hop over to his presentation.
So it's okay?
Kristen, did you give him access?
Should have access now, but I can't see your screen yet.
I just clicked OK.
I just see a black screen.
Right. I didn't.
Oh, there you go.
Oh, there we go. All right. Thank you, Neil. Neil is the Watershed Section Supervisor and Watershed Management Coordinator for the City of Santa Monica. He works for their Office of Sustainability and the Environment. He's been with the City of Santa Monica since 1999, so he knows what's going on in the city. On the side, he also is on the editorial board for the Watershed Science Bulletin. In City of Santa Monica, he oversees water conservation and efficiency programs. He also does watershed management programs. Everything he does is geared towards reducing water pollution and using water sustainably. Before joining the City of Santa Monica, excuse me, he was with the Jacques Cousteau Society, for nearly a decade researching global water issues for different media. So without further ado, this is Neil Shapiro talking about water capture, use, and quality. Thank you.
Great. Thank you for inviting me. Thank CivicSpark and the group for having me. Love to talk about all the stuff that I'm involved in. And we have a similar program that Vanessa talked about in Menlo Park. We have an extensive water conservation program run by a different section of colleagues. So there's lots of information about that on our website. So I'm going to talk about managing our watershed and stormwater rainwater harvesting in our city. That's my focus. And why isn't it moving? Maybe just a little humor to get started. So when I talk about water, I often distinguish between two types of water. So this slide, what do Pott and Edgar Allan Poe have in common with my session? And the answer is you pronounce it potable water or non-potable water, not potable water. Potable water, just for anybody who might be interested in that. I thought that was kind of humorous. Also, working for city government, we always like to make sure that what we do things right and well. And these are some slide shots from around the country, around the world, where things are not always done correctly, and that can always present some problems. So when we're working in our city, when I'm doing my thing, I want to make sure we do things right. Like this slide, this guy's doing some electrical work and his foot's in a bunch of water, not always the best thing to do. Here's a colleague holding one of his colleagues from falling in, versus better ways to secure people. Oops. The left one guy's smoking and he's around flammable gas. So, we want to make sure we do things right. And just recently, the two slides on the right, there's a big sign top right on telling cars to make a right turn, which seems ridiculous, very expensive, where the bottom right photo, just a simple sign bolted to an existing pole is a lot more efficient. So we want to make sure we act accordingly and use our limited resources efficiently. So I'll talk introduction to the problem, and then I'll talk about different approaches we have, and I'll show you lots of examples. And I know I have a short amount of time, but I'll show you lots of examples of things that we're doing in our city. So we're all familiar with, cities have paved over, urban areas have paved over the land, and as a result, when it rains, most of the rainwater now flows off into our surface body waters and cannot percolate into the ground and into groundwater. So that's become a problem, and it carries pollutants. And there's been lots of studies around the country documenting that urban runoff is the single largest source of water pollution in our country. So that's a significant problem, certainly for our city. We're a beach community. We depend on a clean beach, clean waters for people coming, visitors, and tourism coming and helping our economy. Our city, for those who may not know, we're right on the ocean, Santa Monica Bay, surrounded on three sides by Los Angeles. Highly urbanized. We can't expand our city, so any construction is just new construction to replace buildings. We have separate sanitary sewer stormwater systems, so we don't have a combined system. Number of TMDLs for our area that has a lot of different requirements, which maybe the next speaker might talk about in terms of requirements for the stormwater permit, NPDES permit. And we don't get very much rain here. And so we want to make sure we maximize the limited water resources we have and try and maximize the local on-site water resources we have. So when we look at solutions, or at least in my area, we want to look for solutions that have multiple benefits. So for example, in the mid-'80s, early '90s, when we were complying with various regulations for stormwater, everyone was looking for a solution that dealt with water quality, treat the water, discharge it. However, there are solutions that can take care of both problems, and that's where we get into low impact development, design strategy, green infrastructure solutions. And this is an example here. NRDC did a study looking at different solutions where you can harvest your on-site water, treat it, use it on-site, don't discharge it, and that way you solve water quality and water quantity problems. So that's our strategy in our city. We want to mimic nature, work with the water cycle, use all these latest sustainable technologies and strategies, design strategies to be proactive in protecting our watershed. Don't look at stormwater as a waste product, but as a resource. And so focusing on solutions that give us lots of benefits. And to help help me do that kind of work, we have our urban runoff mitigation ordinance that we've had since the mid-90s, and all this is available online on our website and our municipal code. So anyone who's doing new construction or major construction, they have to construct a post-construction BMP, a structure to collect the rainwater and keep it on site. And then we have 2 stormwater parcel fees in our city that bring in about $4 million a year that help us do a lot of our programs to keep our ocean waters clean. Like most cities, probably around the country, certainly in California, back in the late 80s, early 90s through 90s, we started at the bottom of this hierarchy of solutions. Detention was the main solution, just hold the stormwater on site and then discharge it after it's dropped out sediment and any pollutants attached to that. Then we started getting into proprietary solutions. Companies started developing these separation screen filtering systems but to remove gross solid sediments. Then we got into more complicated filtration. Then we started looking into plants to help filter until we've worked up to the top of the hierarchy, where our focus is now on rainwater harvesting. As I said, that accomplishes both water quality and water quantity solutions, and it's the most sustainable solution. So that's where our programs are directed now. And so I'll start by talking about some examples. These are passive examples where we just allow the water to be harvested and infiltrate into the ground. So we have an ongoing program for greening our alleys. We might do 10 to 20 alleys a year, just part of our regular CIP program, part of our regular capital improvement program where we're using alleys. And when we do that, we're putting impervious concrete center swales, so as the water is flowing down the alley, whether it's just the alley water or the roofs of adjacent buildings, that water is going to go into this pervious concrete and soak into the ground. So you can see the top right, the sheen on the impervious asphalt, and then you don't see the sheen for the pervious concrete because the water is soaking in. So this is an ongoing program. We're also going to be doing this at intersections where we have concrete swales going across these intersections, another good place where we can put the product and allow nuisance water to infiltrate into the ground, and it's also during storms, the rainwater go in. We also have an ongoing program when we're redoing either streets or just the curb and gutter. We're putting in impervious concrete again. As the water sheet flows off the crown streets, it obviously goes into the gutter, and all the water is right there, so it makes sense that we could have some percolation going on there to get that water back into the ground. This is an important maintenance point that since most of our streets are lined with trees, we get a lot of tree droppings, a lot of stuff coming off the streets. You want to make sure you have a good maintenance program, a good street sweeping or a vacuuming program so that these locations are cleaned properly at least once or twice a year, so you don't get sediment filling in the voids, and therefore the product will malfunction when you fill in those voids and you don't get percolation. We did a demonstration project many years ago where we looked for a narrow parkway here on the left side, and we had a gutter on the right side. This street is San Vicente on the north part of our city. Again, we thought, well, maybe we can harvest the water flowing down gutters instead of putting in impervious concrete. Just add a catch basin at a location at the bottom of a drainage area, collect the water through this catch basin on the right. It goes through an insert filter to filter out debris, sediment, and then the water, after it goes through that filter, goes into that infiltration zone under the parkway. So in this case, it's filled in with these plastic boxes. There's a variety of products out there, and I'll show you examples shortly. So instead of using rock, we use these plastic products. So that way we get 95% void, and then we can store more water in them. So successful in demonstrating that strategy of extracting stormwater flowing in the gutter and putting it either in the parkway or perhaps somewhere else. And so that somewhere else, we got a grant recently from the state to do what we call an inline stormwater harvesting program. We selected 3 sites in the city. This slide is showing 2 of the sites on one residential area. So instead of adding a catch basin, which is what the previous slide showed, we found existing catch basins. The bottom left shows the existing catch basin, and we tapped in that catch basin, modified it with a little diversion, and so when the stormwater comes off the gutter in the storm drain, it's diverted not into the pipe that goes in the storm drain system, but it goes into an infiltration zone. Top left picture which was similar to the previous slide where the water can infiltrate underneath the parkway. And the middle slide is just showing some of the monitoring and access points for that. We had to do a bunch of monitoring of storms to show that this was an effective solution. On the right side, we tested another strategy. Instead of putting the water under the parkway, we actually augured down the top right slide. You can see the manhole cover, the utility cover, and that's an augured silo about 30 feet deep. So the water is removed from the storm drain. It's filtered of any trash and debris, and then the water goes into this 30-foot water silo and percolates into the ground. And we have signage so that people in the area will see what's going on and learn what we're doing. The third location was on another part of the city, south part of the city. We actually tapped into the storm drain line, not a catch basin. So the bottom left slide, I'm highlighting the utility cover, and that is where the storm drain makes a 9-degree turn coming from an alley, and then this is called Hill Street in our city, and then we diverted the water out of this pipe, and then the middle top slide shows this diversion where a little dam where the water is removed from the storm drain line and is sent to the left, and we have 2 augured pits, top right slide. The first one removes trash and debris, and the second one is our infiltration zone. And in the left top slide, you can see the augured water silo. And then the bottom right, again, shows some signage, and this car is kind of covering over where that infiltration zone is. So we think this is a very effective solution and look forward to doing many more of these. Whenever we do any city facilities, we want to make sure our city facilities have stormwater management components. So this is Virginia Avenue Park when it was rebuilt 10 years ago now, and it has perimeter infiltration zones shown on the left, and the parking lot has traditional asphalt, but the parking stalls have pavers so the water can infiltrate into the ground. This is a new airport we built 9 years ago at our small airport, and we tried out a product called porous asphalt. And so the right slide shows it during a little small rain event, and you can see there's no sheen. The water is soaking in through the asphalt into the ground, and then on the left shows the base layer of rock being applied before we put the porous asphalt over it. Our city has its own big blue bus transit system, so we rebuilt the facility over 2 phases. The first phase at one end of the facility, and we put a big infiltration zone to collect rainwater coming off of some of the hard surfaces and some of the buildings at one end of the facility. And then a couple years later, when they redid about 2/3 of the other end, which is where all the buses are parked and additional facilities, they put in a dual system that includes a top left, a storm filter, and all these canisters have different media in them to filter out a variety of different pollutants, such as heavy metals, which would be more common at this type of facility. And then after that, the water is stored, is detained in a concrete vault, and from here the water is bled off into an infiltration zone, and it infiltrates into the ground. There's the Annenberg facility, which is our kind of a famous facility on our beach that is used for a variety of activities, and there's an infiltration zone actually in the beach area and the sandy area, so good percolation, and all the stormwater coming off of that facility gets infiltrated there. We got another grant to test out converting some parking lots into a more permeable, multi-beneficial use facility. So in our city, we do have a number of parks, and because we're built out, we can't really add any more parks, and we really want to increase the ability of people to recreate around the city. So we converted 1/3 of this beach parking lot. We removed the asphalt and put a product called Net Lawn into it. And this is a grassy product that has a base that makes it structurally sound so you can park on it. So when it's not used for parking, which is most of the year, we open this up and we prevent cars from parking on it, and people can do a variety of different sports or activities, relaxation there. And then when we need it for parking, such as holiday weekends, such as the one we just had Memorial Day or July 4th or Labor Day, we'll open this up for parking so it can be used for parking. So as you can see bottom left, here's an example of when it was used for parking, and the 2 slides kind of on the right is actually the opening of the facility 10 years ago. So we're excited about this particular project. The water, again, percolates into this grassy area. And originally, we wanted this to be a cistern to collect the water, and here's the slotted drain to collect the water. But we didn't get enough money from the grant, so we didn't put in a cistern, but it would have been nice to do that because we actually added more turf to the facility, which means more watering. And of course, when you add that, it kind of goes against our strategy of being more water efficient. Although it does have an efficient irrigation system, that's something to keep in mind where you have to balance the various needs of one's city. So now a bunch of examples of private property putting in infiltration pits or dry wells to comply with our ordinance. The right side picture is a multifamily putting in the pit. On the left side is a multifamily where it's actually raining at the time I was there, and it's kind of hard to see, but it's filling up with water from the rain event. And here are other examples of different plastic products, and I've put the names of them in case you want to look them up, and there's information on our website about them. So again, all kinds of different products out there. These plastic boxes I've been showing, you can have a shallow footprint or a deep footprint and a big footprint but deep to put them in, or you can have a shallow depth but a big footprint to put in these concave products that are very effective. So it just depends on your site, and you want to tailor your products for those different sites. Actually, this one you can actually stack the concave devices after you backfill with gravel. So these are the typical boxes, milk crates that are the most commonly used in our city. And again, going underneath a multifamily parking area. Other kinds of strategies, top right is a parking lot at one of our Santa Monica College. And again, the water sheet flows off into the fire retention area. A very simple and cost-effective solution. The left side there, this is actually a private school next to a freeway. They did not have very much room to put in anything, so they chose to auger and put in, well, something like a silo that fills up with water and percolates. In the bottom right is a supermarket where they put in a rock-filled infiltration zone. Then to deal with, so that's dealing generally with water coming off your roof or your driveways, parking lots. But if you want to make your driveway or parking lot permeable, there's a variety of products that people use in our city to make them permeable. Or if you don't want to do that, you can always put a typical trench or slotted drain, bottom left picture, and that'll pick up the water from the impermeable concrete, and then it sends it actually into the pit, which would be off in the yard. We're starting to get some green roofs in our city. These aren't as practical a solution because obviously, depending on what you plant them with, you may have to irrigate them during the dry season. And again, that requires more water, so you just have to think carefully about that. If you put in a cistern, collect the water, and then use drip irrigation, you can obviously water your green roof during the dry season. Now, as we get away from the passive and into more of the direct or active solution to actually keep the water inside and use it for beneficial purposes, we do have, besides requiring people to pay for these installations during construction, people who want to retrofit their properties, they can also, we have various rebates that pay to redirect your downspout. So here, different downspouts have been disconnected from pipes that go to the curb and send the water to the landscape. This is still a passive one, but we pay up to $40 for that. We do have rebates for rain barrels and cisterns. For rain barrels, we give up to $200. For small cisterns, $500. For larger cisterns, we give up to $2,000 for that. So again, the water can be collected on site and used for landscape irrigation. And again, they come in all kinds of different shapes and sizes. You've probably seen that. The one on the top right is kind of cool. It's a trim line. So if you don't have a lot of space on the side of your property and you want to have still have access to it, you can put this type of a cistern so it hugs the wall, has a big footprint, but it doesn't stick out. Again, all kinds of shapes and sizes, and so a very successful program in our city putting these in. So, and then some homes have been putting in 5,000-gallon cisterns to use the water for irrigation. This is a multifamily, actually use these plastic boxes, 5,000-gallon cistern. It's underneath the front of their property, and it's used for landscape irrigation. This particular project actually matched the landscape plant species to the water needs from a 5,000-gallon cistern. So technically, or in theory, they collect enough water from a couple storms, and that will get them through the dry season. Multifamily with a bunch of cisterns. This is our main library. We put in a 200,000-gallon cistern to use the water for irrigation. We were going to use it for flushing, but this was added at the end of the project, so we weren't able to get it really in for with the design team. Another city multifamily project, a 12,000 gallon cistern for irrigation. I'm sorry, 5,000. And this is actually one of our latest projects. It's our new library. And this is a 12,000 gallon cistern, and the water is actually used for indoor flushing only. So we're very excited about this. We've kind of broken the barrier to actually using rainwater inside, which has been a challenge, certainly at LA County, and dealing with our public health officials and getting permission to do that, and with our public safety officials. So we're excited about that. This is a treatment system, and it goes through different systems: sand filter, microfiltration, disinfection. And then we have some signage and educational information to show people what's going on so they can learn about this. We have a new light rail that goes through our city, just opened up a couple weeks ago, our Expo line, and they have a maintenance facility in our city. They put in a 400,000 gallon cistern system, and they use that water for high pressure cleaning of equipment. Future projects, this is a big project that will be going to construction this year. So this yellow line is marks between Santa Monica on the top and Los Angeles on the bottom. And Los Angeles built a almost 3 million gallon cistern over here in the middle right. And that water is going to be used to irrigate this Penmar Park, but we're going to run a line that takes the water around the park and over to our marine park here. And we're going to use that for irrigation. So we're very excited about that project. We'll be also building another project at the end of this summer at Los Amigos Park. There's a storm drain that runs underneath the street right next to it. We're going to tap into that, put the water in a big cistern, and use it for irrigating the field and for flushing of the bathrooms at the athletic field. And then there's another project we'll hopefully be getting to, a small pocket park, ozone park at the perimeter of Santa Monica next to Los Angeles. And this yellow line is a storm drain, runs right by the park, so it's a perfect source of water to use to irrigate the park. So we'll be getting to that project eventually. And just some other kinds of products out there. As I mentioned, there is actually a product called Water Silo. It's a local company here. We're looking to maybe use those. So instead of filling your silos with grain as they do, you can fill it with water and use it. And then actually a student in Northern California, I forget the town, came up with this concept in a school project, started a company, and it's a water fence. So most homes have fences, and it's like makes sense to just have the fence store the water coming off your roof and using it for that. So quickly finishing up, we have some green streets in our city. We have 3 green streets. We got a number of grants to do that. So the water is either stored underneath the parking lane, or we also have pervious concrete for the water. For the shoulder, the water can percolate. But we also have catch basins here that take the water to our underground infiltration zones, or we have curb cuts where the water can go into our depressed parkways and collect there and infiltrate into the ground. And then our other big one is Ocean Park Boulevard. Kind of was very ugly, and so we added infiltration zones at both ends of this stretch, and we added, again, the parkways depressed to collect water and infiltrate there. And lastly, just talk about our Smurf facility. This is actually a dry weather facility that collects water. It does take some initial storm water, but it's a joint project with the City of Los Angeles. It's the first and only one of its kind in the world, as far as I know, after 16 years. And so we're collecting about 95% of our dry weather flows in our city and some of Los Angeles, and we treat it through 5 different systems, and we use that for toilet flushing, urinals, and irrigation at some of our parks. This is the treatment system. It's your typical treatment system, generally for wastewater. So we have the rotating drum screen removes trash and debris. Our grit chamber removes grit. We have additional waterfalls where people can see the water as it's going through the process. This is our DAF unit, dissolved air flotation. We remove oil and grease. Microfiltration is in this gray container here in the background to remove very small particles to make the water clear and not cloudy. This grassy area is reserved for reverse osmosis system, so we'll be able to produce potable water, which we're planning to in a couple years now. This is inside the microfiltration. And then we have UV disinfection for the 5th system. The water bubbles up here on the right, goes through a U-shaped channel, and the water comes out. Our 3rd waterfall, and we have observation areas such as this one on the right, where you can see information about the facility and explains what's going on, and also decorative stuff, paintings, and other kinds of things to impart to visitors. On the left, we have this access ramp in case anyone has mobility issues. They can't take the stairs, they can use this ramp. There's also a virtual tour of our, if you want to watch it, 13 minutes. I give a tour, you can watch it online. And anyway, so that's our city, that's what we're doing. We're working with nature where we can, using low impact development, green infrastructure kinds of strategies and solutions to keep as much water on site. We do have a sustainable city plan to make our city self-sufficient on local water by 2020. So these strategies I've talked about will help us get there. And if you need to get in touch with me, here's my contact information. Sorry if it went a little long, and thank you very much.
Thank you, Neil. It seems like we lost your presentation a little bit at the end. We'll maybe try to get that back up.
Which
I think
part?
You had some. Yeah, you had some really good slides that I looked at before the webinar that showed the filtration system, but we got stuck at the Virginia Avenue project.
You haven't seen me since then?
Since the end of that.
Virginia Avenue. Oh, I'm sorry, no one said anything. Or Virginia Avenue is here. Virginia Avenue. Hello? Oh.
Yeah, we're not seeing it come up.
You're not seeing any slides? Oh, brother.
Yeah, we can just see the Virginia Avenue slide, but not when you advance beyond that.
So I don't know what happened then. Oh my gosh, I messed up. I think I lost the connection to the website, or, well, I've run out of time, so I don't know that I can do anything about it.
Yeah, that's okay. We actually have a bunch of questions that have come in through our chat box, and so we're hoping to send these presentations out after the presentation is done. So our team will be able to see what you were talking about, just not at the moment. So moving on to the Q&A, one of our first questions is, why is it that rainwater harvesting is not being employed at a statewide level or at a larger scale than just particular pockets of cities or regions? What do you think?
Well, I would say, well, in Southern California, it'll become more popular now. It's just our city was doing this since the late 90s and early 2000s. So because of our new stormwater permit, the emphasis is completely on low impact development, green infrastructure, rain harvesting. So that's going to be happening. The other problem is that we didn't have any codes, water quality standards and plumbing standards to promote this, and there was no code that would allow it, so it wasn't done. And then a lot of public health officials, building officials were all hesitant to do that. They did not like the idea of an alternate water supply on people's properties, and it might cause contamination of a municipal water supply. So all those various factors were pushing against doing alternate on-site water. That's completely changed now, and the state passed a law a couple of years ago that does allow rainwater harvesting. The plumbing codes now allow it in our state, and it's spreading around the country. There's now a national effort that I'm involved in. So it's happening. It's slow, and again, when it's not happening locally, then it's because there's nervousness by public health officials, building officials. Also up north, since you get a lot of rain, a lot of people are like, well, why do I have to do this? Since we get a lot of rain anyway. So a lot of factors going on. Can you see my slide now or no?
No, it's not yet. Going along with that, as a follow-up question, what were some of the barriers to the urban runoff control ordinance and your code updates, and how did you overcome those barriers?
We didn't have any problems passing all of our ordinance in all of our regulations because, I mean, we're the type of city that this is all stuff that we believe in. We have a sustainable city plan. So this is just one aspect of it where we're using our water resources as efficiently as possible. So there has not been anything negative or anything, against doing all the things that I'm involved in. So, which has made my job a lot easier and a lot of fun.
Okay, that's great. We have time for a couple more questions. One of our fellows has asked, how does habitat restoration play into the work you do regarding water quality?
Let's see. Well, in terms of habitat restoration, well, Santa Monica is located in an area where we really don't have any problems with the marine habitats. Santa Monica Bay, while it does have TMDLs, and I guess trash would be the biggest one in bacteria, and all of our programs are geared towards removing the trash and keeping and treating the bacteria. But I don't know if I would call that restoration. I mean, because we don't have a significant problem, whereas in some areas that drain, like the Bayona Creek, they do have wetlands that are being destroyed, and they're trying to work to bring them back. So again, we're kind of fortunate where we don't directly drain to endangered or sensitive environmental areas. Although again, Santa Monica Bay does have its TMDLs, and we do have our programs to comply with the regulations, because obviously people are going to the beaches in Santa Monica and we want them to be as clean as possible, and we don't want people getting sick. So so that's why it's important that we comply with all the ordinances, and that's why we're doing all these different kinds of projects.
Okay. Another person asked, of all the excellent projects that you've helped implement in Santa Monica, what was the biggest success in your mind? I know it's been a decade, over a decade with them, but if you could pick just one or two, what would you say would be your biggest success?
I think the library I spoke about, the new library that uses the rainwater indoors, would be a biggest success, because again, that's using the water indoors, which is important. During the winter season, when you're collecting rainwater, you don't need it to irrigate, so you need to be able to use it somewhere else, and indoors would be the best solution. And then I mentioned some future projects where we'll be using the water indoors. So we're again looking more toward using the water inside, and then we actually have a plan I didn't mention where we're going to be adding about 6 million gallons of cisterns in different locations to collect stormwater and wastewater and treat that to non-potable levels. And then we'll be using that water in our different distribution system. We do have a distribution system for non-potable associated with our Smurf facility. So we'll be expanding that and putting out more non-potable water for uses that don't require potable water.
Okay. All right. Thank you so much. We are out of time. Thank you again, Neil, for joining us. He's joining us from the International Conference on Environmental Science and Technology all the way down in Houston. So thank you for making time in your busy conference schedule to talk to the CivicSpark cohort. We really, really appreciate your time.
Okay. Well, thank you. I'm sorry the slide didn't work out, but they're available if you want to get in touch with me, or you'll make them available. So thank you very much.
Yeah, we'll give out your contact. Thank you so much. Bye, Neil.
Okay. Bye.
All right. Our last presenter is Danielle Dolan. She's the Water Program Manager for our employer, Local Government Commission. She also is pretty much a water expert. She's been working on education, engagement, and advocacy in the environmental realm for the past 14 years. Specifically for LGC, she's working on Water Strong Communities. It's a job training program. She's assisting with code update assistance on stormwater and water energy efficiency. She's facilitating community engagement with legacy mining contamination in waterways. And she is here today to speak to us about the big picture of water, what's going on locally, regionally, and across the state. Thanks for joining us, Danielle.
Thank you, Megan, and it's an honor to be here. I'm just so impressed with every CivicSpark member that I have met, and I'm so grateful for your all dedicating a year to community service. I'm going to enter slide mode now. Let me know if my slides show up properly.
Yeah, it looks great.
Okay, fantastic.
Perfect. Thank you.
Sure. So you all just got a really great in-depth perspective of what Neil is working on in Santa Monica and what Vanessa is working on in Menlo Park. My presentation is going to be vastly different. Rather than giving you a very in-depth overview of a specific project or any one water issue, Megan has asked me to give the big picture overview of water in California. That is a huge topic that I would love to spend hours and hours telling you about, but I've tried to condense it into what I think is the most important overview information that you all need. I'll try to go through the slides relatively quickly so we have enough time at the end for some good Q&A. Maybe we can even pause throughout for Q&A as questions come up. So I really want to make sure that you all get the most out of this session and get your questions answered to the best that I'm able to answer them. Any presentation I give about water, I like to start from the perspective of why we should all care. Water is my chosen profession because I think it's the most important issue in the world, but I know not everyone agrees with me. However, all organisms need water for survival. It makes up 60% of our bodies. It covers 75% of the Earth's surface. And only 2% of that water on the planet is available as fresh water to us. So it's incredibly important that we manage our water resources effectively and put it to the highest and best use. So this morning I'm going to go over the local water management in California and then zoom out a little bit further to regional water supply and management in the state, and then zoom all the way out to the statewide system and how we manage our water supply. And for the local water management, I'm going to go over some specific needs that local communities face and provide a few examples of innovative solutions or ways that local communities are addressing those needs. Under regional water supply and management, I'm going to go over the 10 regions of the state and how each region gets its water and how they manage their water within each region, as well as what are the specific climate change threats in that region. And then from the statewide perspective, we'll talk about watershed function on a macro scale, supply and demand across the state, and then some major statewide agencies and policies. So first, regarding local water supply and management, I'll give you a second to digest this map. California water management is incredibly complex. We actually have over 3,000 local water agencies in the state. We don't know exactly how many there are. The Department of Water Resources is the statewide agency that's responsible for managing all of those agencies, and they don't even have an accurate count of how many there are, which is kind of scary with such an important resource. Nevertheless, that's the state that we're in. I had a professor in graduate school that liked to say that in California we hate big government so much that we'd rather create thousands of little ones. And this is a perfect example of that. Every local municipality may have multiple water suppliers and multiple agencies that manage every aspect of water management, from water supply, wastewater, water quality, ecosystem flows, you name it. They have multiple agencies to cover every single potential use of water. But some of the most acute needs that local communities face are safe drinking water, reliable water supply for irrigation, reliable water supply for human or urban use, sewage contamination and wastewater treatment, stormwater mitigation, and demand management. So I'll give you a brief overview of each of these. The first one being safe drinking water. There are many communities across the state, especially in the San Joaquin Valley and some of our more rural areas, that actually do not have access to safe reliable drinking water. And some of those communities have had to go as far as to pay to truck in bottled water to provide to their residents because their aquifer is contaminated or the infrastructure they have is so old and deteriorated that the water is unsafe to drink. Some of the more innovative solutions for addressing that issue are new technologies on the end user. So putting in some sort of treatment mechanism. There are very high-tech models and very low-tech models that can be installed in single-family homes, multifamily homes, commercial buildings that will treat the water to drinking water quality on a regular basis. Oh, I think I lost the presentation for a sec. The next critical need or issue is the reliable supply of water for irrigation. As most of you probably know, California is the biggest agricultural producer out of our country and provides, I don't know the exact statistic, but a huge percentage of the world's fruits, vegetables, nuts, and seeds come from California. So irrigating our crops is incredibly important. It's also the biggest user of our water supply in California. What many people don't know is that you can't just put any water on a crop. The water that you apply to your field has to be of an adequate quality so that it doesn't harm the crop or kill the crop. And as you irrigate, nutrients are taken out of the soil to grow the plants, and then contaminants or minerals are left behind. So one of the big issues with irrigating our crops and irrigation water supply is the leftover salts, and then our water becomes excessively salty. And what do you do with that excess salt? How do you get rid of it? How do you make sure that your water is clean enough for your crops? And then also, how do you make sure you actually have enough water to treat, to irrigate, to grow the whatever crop it is that you're trying to produce? Some innovative solutions to respond to that need are capturing stormwater and treating it for use. Tertiary treatment is a growing technology where you can treat your water to almost drinking water standards. The companies that treat the water say it's totally safe and meets all this drinking water standards, but we still have state regulations that prevent us from using recycled water for some uses. I think Neil mentioned that a little bit. I won't go into too much detail. But capturing our stormwater and using that or reusing other water provides a more reliable water supply source. There's a great example in the city of Salinas where they are capturing stormwater and treating it for the agricultural region. The greater Monterey Bay area is the biggest producer of bagged lettuce in the state. They refer to it as the lettuce curtain, and they've been able to collaborate with all the water users in their region to capture and treat stormwater and also capture wastewater from the food production facilities and then send that downstream for other uses. The next need is sewage contamination and wastewater treatment. Many parts of our state are still on septic systems, which can leak into groundwater and cause contamination. And we have a huge wastewater supply from every type of industry, whether it's the ag industry, dairies like the picture shown, or our urban wastewater. And that all needs to be treated, and then we have to figure out what we're going to do with that. A new technology that's very promising is the use of biodigesters, where they take the wastewater and they separate the waste from it and turn that into an organic matter that can be added to fertilizers and become a very viable, high-quality fertilizing material, and also cleans up the water, and in the process creates combustible gas that you can then use for energy. An example of this is in Sonoma County. St. Anthony's Organic Dairy Farm is producing enough biogas to almost run their entire farm, all their energy needs on the property, and then also reusing the fertilizer to grow their crops. Next is stormwater mitigation. Neil talked a great deal about this, so I won't spend a lot of time on it. stormwater is a huge, was considered a source of pollution in the state for a very long time. I think Neil expected me to go over the regulations that govern stormwater in the state. Because of time, I don't want to go into too much detail, but there's something called MS4, and that's the regulation that governs the quality of stormwater that you have to meet before it can enter any surface water streams, as well as how much stormwater your property needs to capture when you put in a new development. So Neil talked about green infrastructure, low impact development. The 3 principles of LID are to slow the water down, spread it out, and sink it into the ground so that you can use the plants and biological processes to remove the contaminants and improve the water quality before it does enter into any of our water bodies. And probably what I personally think is one of our biggest critical issues in California is demand management, or the fact that in California we are demanding more water than we can actually provide. And that comes down to the end user and our individual personal practices. We use far more water than we actually need to. And in California, the average per person per day uses about 250 gallons a day per person. The national average is 100 to 150 gallons per person per day. So we're already exceeding the national average, and internationally it's well under 50 gallons per person per day. So cities and counties are required to provide water to their residents, and because of some of our regulatory and policy structures in the state that I'll get into later, our water is priced very low, so there isn't a whole lot of incentive to reduce our water use. But as you're all aware that we're in our 5th year of extreme drought, the state has asked us all to cut back and then gone as far as to require us to reduce our water use. So what many organizations are doing across the state and many municipalities are doing is providing incentive programs for water conservation. I believe Neil talked about some of their rebates, and Vanessa as well. There's rebate programs across the state to help the end user, the resident, reduce their water use at home, and as well as to help businesses reduce their water use on site. So Megan, if we want to pause here before we jump into regional water supply and management, I can ask if there's any specific questions about local water supply and management.
Yeah, someone was wondering how relevant or important the strategies like smart growth and urban growth boundaries are in meeting our water needs. Like how do those strategies affect local water conservation efforts? Or do they?
Could you repeat the first part? So smart growth strategies.
Smart growth and urban growth boundaries are the examples.
Yeah, so the short answer is yes, it's incredibly relevant, and both where we grow and how we grow has a huge impact on our water resources. This topic is covered in depth in LGC's Owani Water Principles in our guidebook, which are available on our website. There's an entire chapter dedicated to how we grow and another chapter dedicated to where we grow that outlines specifically the ways that smart growth principles can reduce the impact on our water resources. In a nutshell, any area that's paved over creates runoff and prevents water from infiltrating into the groundwater supply. When water runs off of a pervious surface, so anything that's concrete or paved over, it then goes into the stormwater treatment system, which historically has just been treated as wastewater and pumped out to the ocean. Now, with new policies and stormwater capture technology and stormwater quality regulations, we're seeing a shift in that where much more of that stormwater is being captured and used, or at least treated before it's discharged. But if we can reduce the amount of area within our cities that is paved over and reduce the amount of suburban sprawl by focusing on those growth boundaries and infill development, then that leaves more open space or green space that water can infiltrate into the groundwater and replenish our groundwater supplies.
Okay. We do have one more sort of local question. This person says, we've seen mandates for residential water use. Is there potential for mandates placed on agricultural water use and agricultural planning?
That's a really great question, and it comes up a lot, especially since the governor passed the mandatory water use reductions for urban water use last year. There was a lot of pushback from local communities on, why are you forcing us to cut back and not asking ag to cut back when ag is the biggest water user across the state. And the reason for that is because ag has already been asked to cut back. The 3 years leading up to the mandatory reductions, ag had their water supplies cut. Most of our agricultural communities and our ag producers receive water from the State Water Project and the Central Valley Project, and this I'll cover a little bit more in the state portion of the presentation. But those are our two biggest water infrastructure projects in the state and provide water to the vast majority of the state, and almost all of our ag producers receive water from one of those, they're giant aqueducts basically, but from one of those projects. And in the drought years, their allocation has been reduced. So every contractor that has a contract to receive water from the state project or the federal project will receive a delivery of a certain amount of water. In drought years, those allocations are reduced by %. So they already weren't getting their contracted allocation of water. So that's the number one reason that they have been, we didn't see a mandatory cutback from the governor on ag. As far as ag planning, my guess is that you're referring to regulating what types of crops farmers plant and where they plant and their harvest practices. The state has shied away from that for basically the state's history. They've not wanted to delve into that realm of policy for political reasons, but from a more pragmatic perspective, farmers are businessmen and they're going to grow whatever is going to get the highest profit. And if we don't regulate what shops sell, then we shouldn't be regulating what farmers grow. And they're going to do whatever they can do to use their water most efficiently because they're paying for their water to grow the biggest crop they can at the highest value that they can. So it's much more dictated by the market.
Okay, we do have a couple follow-up questions to that, but I think it would be good for the sake of time to move on to regional water supply.
Sure thing. So the state is divided up into 10 hydrologic regions, which are basically 10 macro watersheds, and they're numbered here. The first is the North Coast, 2 is San Francisco Bay, 3 is the South Coast, 3 is the Central Coast, 4 is the South Coast, 5 is the Sacramento River, 6 is the San Joaquin River, 7 is the Tulare Lake Basin, 8 is North Lahontan, 9 is South Lahontan, and 10 is the Colorado River. And so these boundaries are drawn based on watershed boundaries, and I'm going to assume everyone on the line knows what a watershed is or what a catchment basin is. But within each of these watersheds or these regions, there's a different microclimate, there are different water supply sources, different regional challenges, and different socio-ecological systems that dictate both where they get their water from, how much water supply they have, how they manage their water, and what their critical issues are. In a nutshell, this is where water comes from and where water goes to across the state. I'm going to give you a second to digest this map and pretend I can hear your laughter. And I'll move on to a real map. But essentially, the dark blue regions is where all of our precipitation falls in the state, where water is collected. And the yellowish brown regions are the areas that receive very little precipitation. And because of our ingenuity in building infrastructure, especially back in the 30s and 40s, we have plumbed California so that we can now move water out of those hydrologic regions to feed thirstier areas from water-rich areas. This is an overview of the hydrologic region's various climate change threats. So the North Coast is in most threat from wildfire and from sea level rise because it's coastal. However, there aren't any large cities on the coast in the North Coast region. It's a very rural area with small towns scattered throughout, but it's also very heavily vegetated. It's rough mountain terrain, lots of trees, and as our climate warms and our precipitation system shifts in the state, they're going to be experiencing more wildfires and higher intensity wildfires. That's their biggest threat from climate change. Region 2, the San Francisco Bay Area, their biggest threat is from sea level rise because they are so densely populated and urbanized right on the coast, and because of the San Francisco Bay Delta. As sea level rises, it's going to flood a huge proportion of that region, which will obviously destroy property. The San Francisco Bay Area receives its water from the Sierras. It's piped in from Hetch Hetchy and the Feather River watershed and the McCollum watershed. So their other risk is more from seismic activity because San Francisco is very earthquake prone. But as far as climate change impacts, their biggest threat is sea level rise. Similarly, for the Central Coast, sea level rise, again, because they have larger cities on the coast. Also because the Central Coast region is heavily reliant on local groundwater supplies. They have very small local groundwater basins that could become infiltrated with salt water as the sea level rises, so that's a big risk for them. Same on the South Coast, again, sea level rise, because they're coastal, obviously, and they have very large cities, urbanized areas on the coast that could be destroyed as tides come up. And also the potential for saltwater intrusion into their groundwater basins, although Region 4, the South Coast, doesn't have a whole lot of groundwater resources. Next up, number 5, the Sacramento River watershed. Extreme heat is going to be an issue. Any of you that live in the valley know how hot it gets in the summer. That's going to continue to intensify. Also wildfires, because we are part of the Sierra foothills. Lots of heavily vegetated areas. We've seen tragic wildfires the past few years, and that'll continue to become worse. Region 6, the San Joaquin River, similarly to the Sacramento River watershed, extreme heat, and also snowpack. Snowpack will impact the Sac River region as well, because as I showed you on the previous map, most of our precipitation falls in the mountains and falls as snow. As our temperature rises, that snowpack is going to be diminished, and currently we have that snowpack to last us through the long summer months because it slowly melts and trickles down through our watersheds into other areas. But as the snowpack decreases, we'll have less of a reliable water supply. Region 7, the Tulare Lake region, very similar, lots of agriculture, big, broad, wide open spaces, they're going to be suffering from extreme heat and be seriously impacted by the reduced snowpack, since that's where a lot of their water comes from as well. Region 8 and 9 cover this eastern side of the Sierras and the peak of the Sierras. Region 9 also includes some of the Santa Ana watershed area. So again, wildfires and reduced snowpack are going to be their biggest climate change impacts. And then Region 10 is the Colorado River system. The southeastern border of California is bordered by the Colorado River. There's not much water left in it by that time, but that entire part of the state is reliant on Colorado River water that they pipe in. And they're in the middle of the desert, so extreme heat is going to be a serious issue, and snowpack up in the Colorado River watershed will be diminished as well. So a little bit on each of the regions, their specific challenges, not necessarily climate change related, but in general, the local water management issues and actions. So the Northern California, we have the North Coast and the San Francisco Bay Area. They will have increased water demand due to population growth. In the North Coast, a big challenge is environmental flows and fish passage. There's many wild and scenic rivers up north, and they're constantly battling to protect those areas for environmental purposes. Also, there is a lot of illegal marijuana growing and some legalized marijuana growing up in the North Coast region, but because it's not regulated, they are destroying and illegally diverting streams to irrigate their crops. And then, as I mentioned, the San Francisco Bay Area is faced with seismic risk. In the North Coast, they have addressed their environmental flows concerns and fish passage issues with lawsuits and local protection. The San Francisco Bay Area, they're focusing on conservation and diversifying their water supply. The coastal regions, both the central and south coast, their biggest risks are saltwater intrusion, reliability of their water supply, and as the regions continue to grow, increasing demand for urban supply. This is where we're seeing most of the water recycling and reuse, as well as the real cutting edge on water conservation and water use efficiency. The valley regions, Sac, San Joaquin, and Tulare, the biggest challenges are groundwater quality because of the legacy of agriculture in the valley and the herbicides, pesticides, and fertilizers all leaking into the groundwater, as well as the excessive pumping of groundwater has both degraded the groundwater supply and reduced the amount of supply. This has led to safe drinking water concerns, and in the face of drought, we have less surface water being provided, so we're pumping our groundwater even faster. There was these challenges that led to the Sustainable Groundwater Management Act being passed at the end of 2015. They're also focusing on end user conservation and conjunctive use across the valley. Conjunctive use is using both your groundwater supply and your surface water supply, depending on what the best use is at that time. So if you can have a system that you can provide either your drinking water or your irrigation water from both surface water and groundwater, then you can rely on groundwater when surface flows are low and rely on surface water when it's plentiful. And then the easterns, North and South Lahontan and the Colorado River, there's a huge emphasis on upper watershed protection as demand for water resources downstream is increased. They are trying to build public-private partnerships with downstream users to invest in upper watershed protection to keep the water in the watershed longer, especially as we see our snowpack diminishing. We need to improve our mountain meadows to serve as the new water bank, so to speak. There's also some major infrastructure needs because most of these regions are very rural. They don't have the resources that the downstream bigger communities have. So their infrastructure is not as fully developed, which is going to become increasingly problematic as that infrastructure ages. So they're working on public-private partnerships, getting additional investment, and a lot of actual habitat conservation. Megan, do we have time to take questions on regional, if there are any that came in, or should we move on to statewide?
I think we should move on. Most of the questions are actually directed at statewide policies, so that would make more sense.
All right, then we'll dive in. This slide I love to show because it provides a smattering of the wide range of water issues that we have to deal with in this state. And for those of you that don't come from an ag background, those giant silver cylinders are silos. The past 5 to 8 years in California, if you're involved in statewide policy, there's a lot of talk about silos and needing to break down the silos. And what they're referring to is the fact that California has managed each of these individual issues or water uses with a separate agency and separate policies. So we have siloed ourselves into very narrowly focused issues. And now we're trying to move away from that and break down those silos and look at water management from a watershed perspective. All of our local and regional water needs and issues are connected to the greater statewide system, both through watershed functions, the statewide supply system, and our policy and management decisions. So local decisions affect statewide issues, and statewide decisions affect local issues. Earlier I said I hope that you all know what a watershed is. This is a watershed. One of my favorite quotes by John Muir: when you try to pick out anything by itself, we find it hitched to everything else in the universe. So this illustrates the fact that we are in a system. Both our water cycle and our land use system are interconnected, and the health and quality of our ecosystem will impact the health and quality of our water resources for human uses and vice versa. This is a map of statewide water supply infrastructure. Earlier I mentioned the State Water Project and the California Water Project. Those are our two biggest plumbing systems. If you look at the middle of the map, you see a red and blue checkered line. That's where the California Water Project and the State Water Project combine, and where they're paralleled. So the California Water Project was actually federally funded. So any of the blue lines on the map, those are federal aqueducts and federal reservoirs from federally funded dams. And the red ones are state-funded dams and aqueducts. And then all the green lines are locally funded and locally built aqueducts or reservoirs for local use. As you can see from this graph, our water supply does not match our water demand. This is our per capita urban water use within each region. The darker blue is more water, the lighter blue is less water. So Colorado River region uses a ton of water, but they don't have a lot of water. It's not a supply area. Whereas the coastal region, they use far less water, and Central Valley is pretty right down the middle. But the North Coast is where a lot of our water is produced, and the Sierras is where a lot of our water is produced, and they're not necessarily using that water. It's being pumped out to other areas. This shows in very clear color dynamic where our population centers are. So the bottom left map, the larger the circle, the more populated that region is, and the colors coordinate nicely with the precipitation map on the right. So those red areas receive next to no precipitation. The green areas receive the most precipitation, and you'll see that they're in complete misalignment. So our state infrastructure and management and statewide water policy is managed by two agencies, the Department of Water Resources and the State Water Resources Control Board. The Department of Water Resources is a water supplier They actually sell the water from the State Water Project to the water project contractors. They're also the managers of water supply across the state and setting policy for water management and monitoring across the state. Whereas the Water Board is the regulatory agency and the enforcement agency that handles water rights and water quality regulations. And the State Water Board oversees 9 regional water boards. So that's the State Water Resources Control Board and then the 9 regional water quality control boards. Quick primer on California water rights. One of the many reasons that California water is a mess is because we have a dual rights system. First, we have riparian rights, which is the more common water rights system used in most of the world. This came over from British common law into the eastern United States and across the country. So riparian rights is when your property has a stream or a water source running through it or abuts a water source, you have the right to use that water source. It's a non-consumptive right, so you can't take that water and not put it back in the stream. And you're not allowed to harm any downstream users. So this is very hard to actually regulate and enforce, but it has some checks and balances in that you can't harm the water source if it's going to have an impact on anybody else that's relying on that water source. This might bring up some of your undergrad classes in Tragedy of the Commons and Common Pool resources. So this was the right system that we had early on in California's history. Then when gold was discovered and the federal government wanted the state to become more populated, they had a lot of incentives to encourage people to migrate out west, and they implemented the appropriative rights system. Basically, anyone can go find any water source and define it as their own to put to a beneficial use. So the incentive was to develop California's water resources. So if you could put that water to beneficial use, you had a right to that water. And it was based on first in time, first in right. So whoever got there first, no matter who had more of a right to use it in your ethical perspective or who would use it for a better benefit, it doesn't matter. Whoever has the earliest right gets all of their water allocation first before anybody else gets any. And we also have a use it or lose it principle, which means if you're allocated a certain amount of water, if you don't use that full amount, then you will lose the right to that water the following year. So this provides a disincentive for water conservation because water rights holders are afraid that they'll lose their water if they try to conserve. That right there is the basis for most of California's water struggles. The State Water Board manages all of the water rights and permits water use, and the water supply of California has been grossly over-allocated. There's an assumption that many of the uses that are permitted, that folks have right to a certain quantity of water, that water will be reused, but many people believe that that has been overestimated, and so we have a system that is estimated to be between 30 and 60% over-allocated, meaning people have the right to use 30 to 60% more water than the state actually has. And then there's actually a third layer of water rights in California that just adds a complicating factor to all of this. They're federally reserved rights. A huge proportion of land in California, especially in our more rural areas, is held by the federal government, whether it's national forest land, national parks, wild and scenic conservation lands, or federal tribal lands. And federal reserve rights are a consumptive use, so they're similar to appropriative in that way, but they are considered to be prime over any local appropriative rights. So the federal government has the right to their water before any of the state rights holders. And the Winters Doctrine provides water for Native American tribes, and their priority date is actually time immemorial. So their water rights supersede all other water rights in the state. Complicating factor, though, is that most of the tribal water rights have not been calculated out to a numerical amount. So they're considered paper rights because they haven't been developed into an actual wet water amount. So that's really complicated water rights in 5 minutes or less. Now we'll talk a little bit about the different governing policies in California. The first one is CEQA, which I'm sure most of you are somewhat familiar with. It's the California Environmental Quality Act. It's our state equivalent to FEMA, the Federal Environmental Management Act. And basically any construction project of any sort has to go through the CEQA process to determine whether or not there's an environmental impact, and if there is an environmental impact, how you can mitigate for that impact. So that has there's a water use component to CEQA and a water quality component for both urban use and for ecosystem use. Then we have the Porter-Cologne Act, which is our state water quality act, so it's the equivalent of the Clean Water Act for the federal government. And the Porter-Cologne Act is what instituted the state water boards and gave them the authority to regulate water rights and set water quality standards. This is really the strongest water policy we have in the state to protect the quality of our water ecosystems as well as our water quality for human use. In 2014, we passed the Human Right to Water Act, which currently is more of a pie-in-the-sky principle. It's not actually being implemented, and they're trying to work out the details on how to actually implement a law like this. But it says that every Californian has the right to clean, safe, and reliable drinking water. And then in regards to urban development, which is probably what you guys are most interested in, we have Prop 26 and Prop 218. And this is also really complicated policy and law that I can't get too into detail on. But these two laws are what dictate how our water rates are set. Basically, both of these laws were passed to protect residents from excessive taxes, especially property taxes, but it requires a 2/3 majority vote to levy any type of tax or fee for any purpose, and you have to provide a direct nexus between the cost of providing a service and the fee charged for it. So what that means is that in California, we don't actually pay for water. We pay for the cost of getting that water from its source to its user. And the water agencies have to show what that cost is and cannot charge you more than that cost. So if you were tracking the news in the past couple of months, there was the San Juan Capistrano case. A huge incentive for water conservation is setting budget-based tiered rates, where essentially if you use more water, you pay a lot more. And that's really great in principle. But because of Prop 26 and 218, it's very difficult to set those tiers at a level in which it will actually trigger a price incentive for folks to change their behavior and cut back on their water use. A couple other important policies. The beneficial use doctrine is what outlaws water waste. Again, this is similar to the Human Right to Water Act, where it's really hard to actually regulate and enforce. But basically, you can't use water for anything that is not considered a beneficial use by the state. And there's a list of, I believe, 40 different beneficial uses. And then back in the early 2000s, there was a huge legislation on the San Francisco Bay Delta, which again is in the news quite a bit, as I'm sure you're tracking, hopefully you're tracking the controversy over the Twin Tunnels proposal to circle water instead of passing it through the delta, passing it around the delta to move water from the Sacramento River system into Southern California. But back in the early 2000s, they were still going through the same battle with the delta, and they established the co-equal goals, which means that Californians value both the economic benefit of water and the environmental benefit of water, and that both of those goals need to be pursued equally, and one does not supersede the other. And then lastly, also in the early 2000s, we passed the Integrated Regional Water Management Act, which is, this is where all that language about breaking down the silos came from. IRWM, or Integrated Regional Water Management, is getting back to the watershed approach, which Neil was talking about. The city of Santa Monica is moving towards the watershed approach and thinking about our watershed function and how we manage all the other aspects of our water supply and our water management practices. So thinking about water quality and habitat and ecosystem restoration and wastewater treatment and stormwater all within the same agency on a regional scale. So IRWM to this point has been a funding mechanism and an incentive to hopefully encourage regions to come together and plan on a regional scale, but there hasn't been any requirement to do so. So basically they're just trying to encourage people to do so with funding, but there's no teeth behind it. And then something missing from this list is SGMA, the Sustainable Groundwater Management Act, which was passed at the end of last year, which is requiring California to finally manage its groundwater resources on a statewide level. Up until this point, as far as a water management perspective goes, we pretended groundwater wasn't there, or that there was no way we could measure it. If your land overlaid a groundwater basin, you could pump as much as you want, and nobody regulated that. A few years back, we passed some very loose groundwater legislation where you had to come up with a groundwater management plan, but only some regions were required to do so. So now we're finally taking it from a statewide perspective and requiring every region to manage their groundwater supplies. This is a timeline of California water through history from when the state was founded up until 2010. I'm not going to go through it because of time, but you'll have access to the PowerPoint presentation and you can go through it. It's actually really interesting. But what's missing at the very end, after the era of conflict, which we say ended around 2009, the new era we're in is considered the era of reconciliation. So rather than fighting over water, agencies and communities and NGOs are all trying to work together to better manage our water resources. And some new directions that the state is heading in, as well as statewide priorities. I already mentioned the co-equal goals and IRWIM, the Human Right to Water Act. These are new, just passed in the past couple of years. SGMA I mentioned, and two directions that haven't been regulated in any way yet. There hasn't been any legislation passed on it, but there's a lot of talk among regional agencies and state agencies are addressing the water energy nexus and the water land use connection. So I had a chance to speak to the water land use connection thanks to one of your great questions earlier. There are now conversations bubbling across the state on how do we address this issue. This is something LGC has been talking about for 30 years, and now others are starting to take notice and acknowledge the fact that there is a connection between how we use our land and the impact it has on our water resources. And then the water energy nexus, the heart of that comes from the fact that there is water embedded in energy production and there is energy embedded in water supply. It takes millions of gallons of water to produce energy because of the cooling system, and it takes millions of kilowatt hours to treat and supply water across the state. Water supply, both groundwater pumping and transporting water across the state, is actually the biggest energy use in the state. So there are grant programs available, and working groups that are trying to address this water energy connection. So these are the state priorities that there's a lot of momentum around these issues now. Just a couple of my reflections on California water. We might have a couple minutes for questions after, I hope. This is controversial, but I believe California does have enough water. We just demand too much out of that water. We need to better prioritize our water use and use it more appropriately, and that can be done through better conservation and water use efficiency. We need to prioritize what we use our water for, dependent on where that water comes from, the quality of that water, and use it for the right purposes in the right place. And this can be done through the one water approach, which is thinking about every drop of water, how many times can that drop of water be used? When I was a middle school teacher and an elementary school teacher, I used to say that we're drinking dinosaur pee. The Earth is a closed system, and the amount of water we have on the planet today is the same water we had on the planet millions of years ago. And it just continues to be cycled through the system. So we have to keep that in mind as we plan and as we use water on a regular basis. And that is it for me.
Thank you, Danielle. That's a great point. We just keep reusing, reusing, and reusing. So why not now? We do have time for, well, technically we're quite over time, but there are some great questions that were sent in, and I would hate to see them unanswered. So one of them has to do with an environmental justice perspective on water. The writer writes, the Department of Water Resources is funding proposals for a disadvantaged communities involvement program. It's aimed at addressing issues of equity in water use, water access, and water quality. Could you tell us more about this program or what to expect?
Sure. So this is an interesting approach that the state is taking. So this disadvantaged communities involvement funding is coming through the IRWM program. So the state is divided up into 48 regional water management groups. So these are governing bodies that came together and came up with a regional plan for managing water. But as I said before, they don't have any regulatory authority. So it's all just based on people choosing to participate. And historically, funding has come through the IRWIM program on a competitive basis, where the state allocates a certain amount of funding to each funding region, which pretty closely follows those hydrologic regions I showed you earlier. And then all of the regional water management groups within each of those funding areas has to compete for some chunk of that pot of money. So what they're doing this time with the Disadvantaged Communities Initiative is all of those regional water management groups within the funding area have to apply together for the whole chunk of money. So they're forcing these groups to coordinate, which in many ways is a good idea, because that's the heart of IRWIM is to coordinate and collaborate. But it can be extremely challenging where some of these funding areas may have 4, 6, or even 10 regional water management groups that have to somehow come together and agree how to best use this funding to engage disadvantaged communities. And the way the state is defining disadvantaged communities is both through Cal and Biro screen and through economic status. And I think there's a third loop where basically the regional water management group can define some community as disadvantaged on whatever factors it decides, as long as they can justify it and provide backup to the Department of Water Resources. And the goal is, just like the name says, to involve disadvantaged communities in the IRWIM process and come up with projects to address their needs. So the first round of funding is for planning, so to do community needs assessments and to do disadvantaged community analysis to see what communities are in your area and how best to engage them. And then there'll be 2 more rounds of funding that are specifically for disadvantaged community projects. And that can be anything from a community engagement project to building a new water treatment facility to putting in end user treatment technology or a habitat restoration project. So the types of projects is pretty much wide open.
Okay. Thank you. Thank you very much. I'm looking through the other questions, and I think most of them have been answered roughly through your presentation and the other 2 presentations. So since we're over time, I'm going to call a hard stop on that. But really appreciate your time, Danielle, especially in your busy schedule. It sounds like you have your hands in a ton of projects, and we really value your time and your expertise. It's a lot to cover. Water is quite complicated. So thank you very much.
Thank you, Megan. And again, thanks to all of you CivicSpark Fellows.